Hey everyone, welcome to this beginner-friendly tutorial where we go from knowing nothing about Unreal Engine 5 to making this small game that you see right here. So, the game we are going to make today with Unreal Engine 5 is a small shoot-them-up game in which you play as Toby, a mage that has to survive to waves of enemies, either by avoiding them or by throwing projectiles at them with the spacebar. So, as you can see on the top left corner of the screen, there's this small pink gauge that represents the current health points of the player, and once it reaches 0, up, you can see that there's a menu showing that the game is over, showing your current score, as well as a restart button that restarts the game once you click on it. For this tutorial, we're going to be using this Unreal Engine 5 project that I made, something that is really easy to follow along with. So all you need to do is go to the description below and download the project that is linked, and once you have it downloaded, you can open the Unreal Engine project file and you can join along with me. So with all of that being said, let's start game deving. Once you open this Unreal Engine 5 project that I provided with this tutorial, you land on the Unreal Editor user interface, which is shown here. So now I'll do a brief overview of the main elements of the user interface that we are going to be using in this tutorial. One of the main elements of the user interface of Unreal Engine 5 is the viewport that you see right here. The viewport is like a window into the 3D world of the game we are creating, and this is where the action takes place. So to be more precise, in Unreal Engine 5 terms, the 3D world you see right here is called a scene, and everything that is placed in the scene is called an actor. So there's a lot of ways to navigate inside the viewport, but the main one I use is this one. First, you hold the right mouse button so that you can control the camera, and then you can use the WASD keys to move left, right, forward or backward, and Q and E to go up or down. Of course, you can place actors in the scene either by placing assets that you created with Blender, for example, or by using two useful tools of the editor. The first one is the Quixel Bridge tool. You can access it by clicking right here and then select Quixel Bridge. It will open this window, and Quixel Bridge, you can use it to search for top-notch 3D assets and materials that you can use for free in your Unreal Engine project. The other way to place actors in the scene is to use the Place Actors panel or menu that you can access here. And here you can see that you can place lights, shapes, visual effects, volumes, and everything else that's useful for your game. So let's try to place a cube. I'm going to go to Shapes, Cube, click and drag it in the scene. As you can see, there's a cube that appeared in the scene. And with this cube, you can translate it by clicking right here and select the axis along which you want to translate the cube. You can also rotate it by clicking right here. And you can rotate the cube along each axis. And you can scale the cube by clicking right here. You can scale along each axis or along every axis. Also, you can press the spacebar to switch between these modes. On the right-hand side of the user interface, you can see the world outliner right here, which references all the assets that are currently placed in your scene. So, for example, if I select VFX clouds, you can see that the clouds will be selected in the viewport. And if I select the cube here, you can see that the cube is highlighted in the viewport, and we can translate it, rotate it, and scale it. Below the World Outliner tab, you have the Details tab right here, which, as its name suggests, gives you details about the asset or the actor that is currently selected in the viewport or the World Outliner. So, for example, if I select the cube right here, you can have information about its location in space, its rotation, as well as its scale. So here, if I put 1 in the scale X, you can see that the cube shrinks. If I put 0.5, it shrinks again. And here you have a lot of other information that we won't be using in this tutorial. So for now, we can delete the cube and continue our presentation. The Unreal Editor user interface is modular, which means that you can get any tab and put it wherever you want. So I can put it right here, right there, or put it back where it was at the beginning. Also, just so you know, you can dock any panel in the sidebar by right-clicking here and selecting Dock to Sidebar. Once the panel is docked, you just have to access it by clicking right here. And if you want to undock it, you can right-click and select Undock from Sidebar. If you close any panel, just like, for example, the outliner, you can restore it back by clicking here, Window, and select Outliner. On the bottom side of the user interface, you have the content drawer right here that gives you access to the folders of your project. Here you can organize your assets and navigate inside the folder structure of your project to open specific assets. Another cool thing of the content drawer is that it can be accessed anywhere in the editor by pressing Ctrl and spacebar. So let's say I open this asset and want to access another one. I can press Ctrl and spacebar on my keyboard and open another asset. Let's say this one. Finally, at the top of the user interface, you have the toolbar, which gives you access to a lot of things, such as placing actors, as we saw earlier, but you can also access different editor modes that you see right here, such as modeling, fracture, brush editing, animation, and anything else that you see here. And here you have the play button, which allows you to launch the game. You can launch the game by clicking on this button, and you can stop the execution of the game by pressing the escape button on your keyboard. The game can either be launched directly in the editor, like this, or in a separate window by clicking on these three dots right here and selecting New Editor Window. Here, when the editor window is launched, you can also escape the game by clicking on the escape button on your keyboard. So, now that we know more about the user interface, let's have a closer look at the prototype we have here. So, if I launch the game, as you can see, enemies spawn at the top of the screen at regular intervals and constantly go towards the bottom of the screen. Just so you know, every 5 seconds, the enemy spawning rate increases by 1.5 until it reaches 10 enemies per second. The goal of this course is to create a playable character that will help us defend ourselves against the enemy, and we'll do it right away by creating our first blueprint in Unreal Engine 5. To create our first blueprint, we are going to go in the content drawer by pressing Ctrl and spacebar on our keyboard. I'm going to go in the content folder, Funky Shooter folder, and here I'm going to create a new folder by right-clicking and selecting New Folder. I'm going to rename it to Blueprints. I'm going to access this folder, right-click and select Create a Basic Asset, Blueprint Class. So when I click on Blueprint class, I'm prompted with a dialog box that asks me what type of object I want to create. So as we saw earlier, an actor is an object that can be placed or spawned in the world. We can see that pawns are a special type of actor that can be possessed and receive input from a controller. Then there's the character type of object, which is a special type of pawn that includes the ability to walk around. Then we have the player controller, game mode base, actor component, and scene component. So the actor we want to create needs to be controlled by the player. So at least it should be a pawn or a character. You might think that we need to choose the character class, but contrary to what one might think, this class is too complex for what we want to do. So for now, we'll keep it simple and select the pawn class. I'm going to rename this pawn class to BP for blueprint underscore player. And then I'm going to open it by double-clicking on it. So now we created a blueprint, but what exactly is a blueprint? A blueprint is like a construction diagram that helps us define all the properties of an object we are going to use in our project, whether it be an actor, a character, the user interface, or anything else that is required for our game to work as intended. When you open the blueprint of an actor, you're presented with this user interface, which is composed of many elements. First, you have the viewport, which gives you a visual representation of the actor you're building with this blueprint. Then here, you have the Components tab, which references all the building pieces of your actor. And here you can add static meshes, sounds, VFX, as well as other cool functionalities. Here, you have the Details panel, which shows you the details about the things you select in your interface. Here you have the Blueprint tab, which shows all the variables and functionalities that you are going to create for your game. Don't worry if you don't understand these words, we are going to cover them later in this tutorial. And here we have the construction script right here. The construction script is the place where you can execute pieces of code when an instance of this blueprint is created to perform initialization actions. And finally, we have the event graph right here, that contains a node graph that uses events and function calls to perform actions in response to gameplay events associated with this blueprint. Okay, so now that the presentations are done, let's add some actor components to our playable character to create the visual aspect of our character. So components in Unreal Engine 5 allow us to add functionalities to our actors, and for example, we can add an actor component that can simulate the movement of a projectile, or a component that can help us easily manage health points for our character. So I'm going to add my first component by going here on the Add button, clicking right here, selecting skeletal mesh, and then by selecting the skeletal mesh right here, I can go to the mesh category here and select none, and then select sk_Toby. So now we can see the character in the viewport, and just so you know, in Unreal Engine 5, the x-axis of a blueprint represents its front side. So I'm going to select the skeletal mesh here, and you can see that the x-axis point this way. So I'm going to take the rotation mode by clicking here and then rotate the character 90 degrees to the right so that he looks down the x-axis. So the particularity of skeletal meshes is that they have a skeleton assigned to them and therefore can be animated. So our character Toby has a cool flying animation that we can use here. So I select my skeletal mesh right here and then go to animation here. Select animation mode, use animation asset, and then here I'm going to select Toby fly smooth. Oh, sorry, I'm going to go in the middle of the screen. Toby fly smooth. Now you can see that our character is playing a small flying animation, but he's no longer placed at the middle of the blueprint. So I'm going to take the translation tool here and reposition him so that he's right at the middle of the world here, minus 120. So this way, the character is placed at the center of the blueprint, and we can go along to the next part of the tutorial. Now that the visual representation is done, we can try to put our character in the world. So I'm going to open the content drawer, control space. I'm going to take the player up, put it in the world here. Let's translate it and put it right at the center of the world. Let's go here in the details panel and put 0 in the location X, 0 in Y, and 0 in Z so that the character is placed at the center of the world. So if I launch the game, we can see that the character is present, but the world doesn't react to our inputs. This is due to the fact that the pawn is not automatically possessed by the player controller, which represents the interface between the player and the game. To fix that, we need to specify that this pawn will be possessed and therefore controlled by the player. So I'm going to exit the execution of the game by pressing Escape on my keyboard. I'm going to select the BP_player in the viewport. And then here in the details panel, I'm going to search for auto possess. Auto possess, and then I'm going to select auto possess player 0, which is the player 1, in fact. So now, if I launch the game, you can see that it still doesn't work, and we are going to see why in a second. So now we took possession of the character, but it's still not responding to our inputs. Why? Because this is due to the fact that we didn't set up the inputs of the game, as well as how the character is supposed to move based on the player's input. To begin with, we are going to set up the inputs of our project so that we can send instructions to our pawn for going up, down, left, or right. And before going further, please note that in Unreal Engine 5 you have a system that has more customization capabilities, which is the enhanced input system. But since this is a beginner-friendly tutorial, I'm going to use the simpler method that we are going to use right here. So I'm going to escape the game, and then I'm going to go here, Edit, then Project Settings, and here we have the option Category Engine Input. Here we can add axis mappings. I'm going to click on the little plus sign, and I'm going to add a move up, and then add another one called move right. Here, I want to use my gamepad to control the character. So, move up, we're going to use here gamepad left thumbstick Y axis, which is the axis that's going up or down on the gamepad. And for the move right, we are going to use the gamepad left thumbstick x-axis, which represent the axis, the horizontal axis on the stick to go left or right. So what have we done here? So here we have created two inputs for our game. One is the move up, which is represented by the vertical axis of the thumbstick. So if we go up, the move up will return 1. If we go down, the move up will return -1, and we can use it to convert the move up into its opposite, which is move down. Move right works similarly, so if I go right, I'm going to return a scale of 1, and if I go left, I'm going to return a scale of -1, which will inverse the right vector and put the character to the left. So if you don't have a gamepad, you can assign keyboard-based input, and the problem is that contrary to the gamepad where you have only one stick to go left or right, with the keyboard you need to use two buttons, one for going left and one for going right. To simulate that, we are going to use the scale parameter, -1, so left means that we are simulating the stick going left, and 1 means that we're simulating the stick going right. So, how do we add the keyboard bindings? Here we have move up, we're going to click on the plus sign 2 times, and here we are going to click on the little keyboard right here, and you can then press the button you need to assign to move up. So I want to assign the move up action, so I'm going to press W for WASD, and here I'm going to assign the move down to S. How do we define up or down between these two bindings? Here, one, as I said earlier, represents the fact that the stick is tilted up, and -1 here means that the stick is tilting down. So we're going to do the same thing for move right. Here, I'm going to add 2 inputs. I'm going to click here and select D for going right, and here A for going left. So D has a scale of 1 for going right, for tilting the stick right, and A has a scale of -1, which simulates the stick which is tilt left. So I'm going to save and close the project settings. Okay, so now I'm going to open the blueprint of the player, content drawer with Control and Spacebar. Open it. And just so you know, in Unreal Engine 5, when the game plays, each time the frame needs to be refreshed, everything including the position of each actor, the lighting, the sounds, the visual effects, and many other things are recalculated. This is done automatically, but we as programmers have the ability to influence what is going on in the game with the help of what we call events and functions that are triggered when a button is pressed or when a certain condition is met. So here I'm in the event graph of the blueprint player, and we have 3 events here that are used a lot when coding with blueprints. The first one, the begin play event, is an event that is triggered when the actor comes into play. So to show you how it works, I'm going to add a print string here. This will print hello to the screen on the right hand corner. So if I launch the game, you can see that there's hello printed here. Oh, it disappeared. Here, hello right here. So begin play is triggered when the actor comes into play, and then I'm going to delete this. The event tick is triggered each time the frame is refreshed. So 60 times per second for a 60 FPS game and 30 times per second for a 30 FPS game. So same here, I'm going to use a function called printString to show you that it will be called a lot of time in a second. So let's press play. And here you can see that there's the word hello that spawned a lot of times, so 60 times per second, for example. And this is how the event tick works. The last event, which is called event actor begin overlap, is triggered every time the actor overlaps another actor. So this event will be used later in this tutorial, but now we are going to make a focus on these 2 nodes. Here we have what we call in Unreal Engine 5 blueprint nodes. Their anatomy is quite simple to understand. On the left side of a node, we have its inputs, and on the right side of a node, here and here, we have its outputs. As you can see, each input and output is represented by different pins of various shapes and colors that I'm going to explain to you right now. So what you see here the white wire between the two nodes is called an execution wire, and this gives the execution order of the nodes when the game is played. In this case, we read from left to right, and the event tick is executed first, then the print string, then whatever is wired to the right of the print string node. Next, at the right side of the event tick, you can see that there's a green pin called delta seconds, which represent a number with a floating point value. To be more precise, each time the event tick is fired, we can get this value, which represent the time elapsed between this current frame and the previous frame. And finally, at the left side of the print string, we can see a pink pin which represents a value of type string. We call it an input parameter of the print string node, which will be processed and printed to the string as a text message, as we saw earlier. So here, if I press play, we can see the word hello. If I change the word to boom, we can see the word boom printed on string, and this is the input parameter of the print string node. So now we are going to delete all these nodes because we don't need them. And if we need to use them later, we can right click in the graph and type the name, for example, begin play, and call the event begin play again. So now I delete this and we can move on with the tutorial. Okay, so now that we've talked about the basic anatomy of a node, we are going to use an event that will help us do something when a button is pressed. What's cool is that since we declared our inputs here in the project settings, we can use events that have the same name and that will react to whatever is inputted by the player when using the keyboard or the gamepad. So here I can right click in the event graph of the blueprint player and type event move up. So this event is an axis event that's triggered every frame and returns an axis value which represents the current tilt angle of the gamepad stick. So for example, we can see here axis value, which is a number as we saw earlier. And if I tilt the gamepad up, this event will return the value 1. If I tilt the gamepad down, so here, this event will return the value -1. If the stick is at rest, then in that case, the axis value will return 0. So now we want to move the character up or down based on the axis value. To do so, we need to know what means moving up or down. So I'm going to go in the viewport right here, and we can see here the axis of the word here. And as we can see, depending on the axis of the word, we find that moving up or down means moving along the x-axis of the world. Okay, let me go back to the blueprint of the player, and to do so we are going to call a specific node called add movement input. So here I'm going to right click and search for add movement input. Here, this one, pawn input and add movement input. I'm going to click. I'm going to connect the execution pin, and then I'm going to connect the axis value here, and the world direction, I'm going to put the value of 1. So what have I done right here? I'm going to explain to you when add to movement input is called, it takes a vector. In this case, the x-axis, which is inputted right here in world direction. So x equals 1, y equals 0, and z equals 0. Then it takes this vector and multiply its value by the scale value. So the scale value is fetched with the axis value of the input axis move up. So if the player tilt the stick up, we are going to get a value of 1 here. 1 will be multiplied by the x-axis of the world, which gives the same axis, the x-axis pointing forward. So the player will move forward. If we tilt the stick down, the axis value equals -1. -1 will be multiplied by the x vector, and the x vector will point backward. In this case, the character will move down. Then, if we put the stick at rest, axis value will be equal to 0. The world direction will be multiplied by 0, and then we will have a null vector, which means that the player won't move. So now you might think that if we launch the game, the player should be moving up or down. But when we click on the play button, you can see that the character is still not moving. Why? Here, if the character is not moving, it's because we didn't specify how it was supposed to move. For example, should it fall due to gravity? Should it roll left or right? Should it teleport to a specified location? And in our case, since the player is supposed to be flying in air, we can assume that floating around is a great solution. What's cool with Unreal Engine 5 is that it has a built-in solution just for that. So we are going to use a component that allows us to achieve this kind of movement easily. So I'm going to quit the game. I'm going to go to the blueprint of the player. And here in the viewport, I'm going to add a new component here. And the component we're going to add is called floating pawn movement. Floating pawn movement. I'm going to click here. I'm going to select the floating pawn movement, and here in the details, I'm going to define a speed for the character. So here we have a movement speed of 1200. I'm going to put it at 1000. And now, if I launch the game, you can see that our character can move up and down. So now that's great. Now we want to know how to move left and right. And if I go to the viewport, you can see that moving left and right means moving along the y-axis of the world. So we are going to implement this. I'm going back to my BP player, to the event graph. Now that I have input axis move up, I can call the second input that I binded in the project settings. So here I'm going to right click, call move right. I'm going to get an execution wire here, and then call add movement input. So same thing as for move up. I'm going to put axis value in the scale value here, and world direction, we will put the value of 1 in Y. So this way we are telling the add movement input that we want to move along the Y-axis of the world. And depending on the input that we are getting from the gamepad, we are going to move left or right on this Y-axis. So now I'm going to launch the game, and now I can move in every direction in the game. It's cool, right? So now before moving on to the next step, there's an important thing that you need to know. Every time you write a code, you should comment it. This will prevent you from coming back a few months later and not remembering how it works. So to add a comment, you just have to select the code you want to comment and press the C button on your keyboard. This will add a comment, and you can type whatever you want to remember what this code does. So now I'm going to type move the character up, down, left, and right. So now that the code is commented, there's a cool thing to know is that if you select the comment bubble here, you can grab it and move it around. It will take all the code that is contained inside the comment bubble and move it everywhere you want. Another thing I forgot to mention, if you right click on the mouse button and move, you can move in the graph. The graph is like an infinite graph that you can move around. And here you can zoom with the mouse wheel and select things with the left mouse button. Now that we have everything done, we can save and compile. Compiling the code means telling Unreal to check if the code is good. If it's not good, it will show you an error. Okay, so now I would like to launch the game to show you something. Click here. And now you can see that we can move around, but we can also go off screen here at the bottom of the screen, as well as at the top of the screen. So we would like to prevent that. And if you paid close attention to the 3D scene, you can see that there are boxes around the player. The box at the top, this one, is responsible for spawning the enemies. We can see that by launching a simulation of the game, which launches the game without actually playing it. How do we do that? We go here, click on the 3 dots, and select Simulate. You can see that the game is launched and that enemies spawn through this top box, this spawner. As you can see, once the enemies go off screen, they are automatically destroyed. So the other boxes that are around the player are boxes that are supposed to prevent him from going out off screen. So why is it not working, you might ask? It's simply because even though the boxes have collision activated, the character does not. So we are going to add collisions to our character. So now I'm going to go to the BP player, and to activate the collision of the player, we need to add a new component. So I'm going to go here, add, click, I'm going to type collision, and I'm going to select sphere collision. So as you can see here, we have a sphere. We are going to put it back at the center of the blueprint. And then I'm going to increase its radius by going to the details panel here and putting in the sphere radius a value of 64. Okay, so the sphere is cool, but we would like it to make the root of the blueprint. The root means it's the parent component on which everything is attached. Here you can see the default scene root, which is the small drawing that we saw earlier right here. So we can pick the sphere here and put it right here on the default scene root. So now the sphere is the root component of the blueprint, and adding the collision component is not enough. We need to define what type of object it is so that it can react correctly. So I'm going to select the sphere collision here, and then in the details panel right here, I'm going to put myself on the left side of the screen. The details panel, you have the category collision here, and in the collision, you have collision preset. So now you have all the parameters. If it's like this, you can click right here to unfold the collision presets. And just so you know, in Unreal Engine 5, there are 3 types of collisions. It's more complicated than what I'm going to explain, but just remember that in general, ignore means that the sphere collision will go through everything as if it didn't exist. Overlap means that it will go through everything, but if it overlaps something, an overlap will be registered, and we can do something when this happens or not. The final type of collision is the blocking collision, the block, which means that the sphere collision will block everything from passing through it. So here we can see that the preset overlap all dynamic is assigned to our sphere collision, which means that it's an object of type world dynamic and that it overlaps every other object types, whether it be pawns here, vehicles here, or anything else. Okay, you can see that overlap is activated for each type of object. Since our character is a pawn, this preset is not adapted to our character, and we can change it to best fit our need. So here we can select collision preset, and since our character is a pawn, we can select pawn. So now that we selected pawn, we can launch the game. So click here and selected viewport. And here you can see that we can't move past the screen. We need to stay in the screen. So now that it's working, we're going to see how to deal damage to the player. Okay, so now that we know how collisions work, we are going to use this knowledge to deal damage to the player character. So if I launch the game, you can see that the enemies overlap the player. The collisions of the enemies, in fact, that are going towards the bottom of the screen, were set up so that they overlap the player and don't block him. I'm going to go in the blueprint of the player, and what's cool is that Unreal Engine 5 has an event that can be triggered every time the player registers an overlap with another actor. If you remember well, we even talked about this event earlier in this course. Now I'm going to go to the event graph, and here I'm going to go over there, right-click, and call actor begin overlap. Okay, do you remember this event? We used it in the beginning when we created the blueprint of the player. And as I said earlier, this event is called every time our character overlaps another actor, and we can verify it by adding a simple print string. So here, I'm going to use an execution wire and call a print string. So now, if I launch the game, you can see that every time that I'm going to overlap another enemy, there will be a hello that will be printed to the screen. Okay, so now that we know how the event actor begin overlap works, we can try to find a way to deal damage to the player each time an enemy overlaps him. But in order to deal damage to the player, we need him to have health points. So how are we going to do that? We are going to create our first variable. So how to create variable? You go here on the left side of the interface and you have the word variables, which references all the variables that compose this blueprint. So here I can click on the plus sign to add a new variable. I'm going to give it a name like current health points, for example. And then I'm going to define its type. Here I'm going to click on Boolean and select real. If you remember well, real is a number, as we saw earlier with the axis value. It's a number with a floating point value. So what we've created is called a variable. It's like a box that has a name that can be used by another box in the same blueprint. That name is called here current health points for the variable that we just created. And this type of variable, this variable has a type and can store only one type of value, whether it be a number, a text, and an actor, or anything else. So our variable current health points is of type real, which means that it's another word for a number with a floating point value. So now you can see right here, okay, so I'm going to put myself in the middle of the screen, mid here. You can see right here that it says default value, please compile the blueprint. So we want to compile the blueprint here. And now you can see that current health points appeared, and you can set a current value, okay, a default value for this variable. So I'm going to put the value of 100 to represent the value of 100 health points when the player begins playing the game. So now that we have a variable that represents the health points of our player character, which are equals to 100 in that case, we can use the actor begin overlap event to deal damage to the player each time an enemy overlaps him. So if you take a closer look at the event actor begin overlap, you can see that it has a parameter called other actor, and this parameter is a reference to the actor that triggered this event by overlapping the player. So since we want to deal damage only when the enemies overlap the player and not the other actors of the scene, for example the clouds, we need to verify the type of the actor, which is referenced by the variable other actor, the parameter other actor. To do so, we are going to use a special node called cast2. So I'm going to delete my print string, and then I'm going to take the pin other actor and call a node cast2 bp underscore enemy. Oh, I'm going back to the right side of the screen. Yes, I'm going to call cast2 bp enemy. When this event is called, actor begin overlap, Unreal Engine 5 doesn't care if it's an enemy or a cloud or a box collision. So what you can see here is that if you put your mouse over the other actor, you can see that it's an actor object reference. At this point, Unreal just knows that an actor of whatever type overlapped the player character, and that's it. Okay? The cast2 node allows us to verify the type of the object. And here we ask Unreal if the other actor is of type BP enemy, which is the blueprint I created to represent the enemies of the player. To see that, we can summon the content drawer, go to base game, core, and then here you have BP underscore enemy. So this is the blueprint that I created for the enemies of the player. So if I close this, as I said earlier, the cast2 node allows us to verify the type of the object, and we ask Unreal if the other actor is of type enemy. If other actor is of type enemy, the code exits through the top execution wire, this one. If not, it exits through the cast fail execution wire. The asBP enemy output parameter, this one, is valid only if the cast succeeded. So only when we go through this execution wire. So now I can hover my mouse over the asBP enemy parameter, output parameter, and we can see that is an BP enemy object reference. So at this point, this other actor, we know that it's a BP enemy when we go through this execution wire. Okay, so now that we are sure that we are overlapping with a BP enemy, we can deal damage to the player by removing some of his health points. To do so, we are going to use the two operations that we can use with variables. The first operation is the set variable operation. To use this operation, we can get the current health points here, drag it into the graph, select set current health points, and connect it to the cast succeed, this one, okay, the top execution pin. So what does this operation do? The set variable operation allows us to change the value of a variable. So here, for example, when an enemy overlaps the player, we change the value stored by the variable current health points to 0. As you can see here, we assign the value 0 to the current health points. Don't forget, a variable can store only one value at a time, and this means that as soon as we put 0 in the variable, it's no longer equal to 100, and this previous value, 100, can no longer be accessed. So the problem is that we don't want to bring the player health points all the way to 0 as soon as an enemy overlaps him. Instead, we want to decrease his health points progressively by a defined amount. Okay, so to do so, we are going to use the get, which is the second operation available to use with variables. How to use the get? We take the current health point variable, drag it in the graph, and select get current health points. The get variable operation allows us to get a copy of the value that is stored in the current health points variable. Once we have a copy of the value stored in our variable, we can apply a simple subtraction on it and put the result back into the variable. I'm going to implement a simple logic here. I'm going to take the current health points, the get current health points. I'm going to draw a cable and type minus on my keyboard. This will show the subtract operation. I'm going to click on it. And then here, I'm going to connect this one right here. And the pin, the bottom pin of the minus operation, the subtraction operation, I'm going to put the value of 10. So here we used a subtraction node. What this does is take the current health point value, which is equal to 100, removes 10 from it, which equals to 90, and store it back into the current health points. So at this point, the current health points stores a value of 90. So later in this tutorial, we are going to code a life gauge that will be displayed at the top left corner of the screen. But for now, we are going to use our friend, the print string, to show the current health points of the player. So I'm going to right click here, type event tick, and call it right here. Okay, here I'm going to take a print string. I'm going to take the current health points, make a get current health points, and then connect this in the input pin in string. This will create this node. I'm going to explain to you what it does. And here in the duration, we're going to put a value of 0. Okay, so this code, how does it work? It takes the current health points, the value that is stored in the variable, converts it to a displayable text, and inputs it as a parameter of the print string. Here, I've set the duration to 0 so that the print string is displayed for only one frame. And since the event tick is called every frame, this text will be displayed at any time at the top left corner of the screen. So now if I launch the game, you can see that I have 100 health points. And as soon as I overlap enemies, my health points decrease by a value of 10. Okay, so now if we play the game and take enough damage, up. Look at the top left corner of the screen for the current health points. You can see that the player's health points continue to decrease even after they reached 0. So like now they go minus 10, minus 20, minus 70. So to prevent this, we are going to implement the end of the game, which will be triggered as soon as the player's health points reach 0. So I'm going to go in the blueprint of the player and the actor begin overlap. And to do so, each time we decrease the player's health, we would like to be able to check if the new value stored in the current health point variable is less than or equal to 0. To do so, Unreal Engine 5 has a blueprint node called branch that allows us to do some execution flow control. So now I'm going to right-click, type branch, and select flow control branch, this one. Then I'm going to connect the set current health points node to the branch node. The branch blueprint node is easy to understand. When we go through it, it needs to check if the condition input parameter is true. The condition input parameter is this one. So here it is checked. If the condition parameter is true, the code continues to execute by going through the true execution pin, this one. If the condition is false, like this, the code continues to execute by going through the false execution pin. So what condition do we need to check? It's easy. We need to check if the new value stored in our current health points variable is less than or equal to 0. If it's true, then we show a message telling that the player character is dead. To do so, we are going to get here. Here we have the new value of the current health points. We can get it here or by getting another get operation. You can choose either, it will work. So here I'm going to draw a cable and type less equal. Less equal. Then I'm going to connect this new node to the condition of the branch. So what have we done here? We took the new value of the current health points variable, then compared it to 0 and connected it to the branch. So what happens is that as soon as the current health points value is less or equal to 0, we are going to go through the true execution pin. As long as the current health points are still above 0, the player has no reason to die and we can continue doing everything we are doing. So here I'm going to draw a print string. And in this print string, I'm going to type I'm dead. Now I can launch the game. And then as soon as my health points reach 0, 30, 20, 10, and now look at the top left corner of the screen. Now it's displayed, I'm dead. Now, instead of printing text on the screen when the player is dead, we would like to create a simple menu that will be shown on the screen as soon as the player's health points reach 0. The menu will show not only the final score of the player, but also a button to restart the game. To do so, we are going to use another kind of blueprint that is responsible for showing user interfaces on screen, which are called Widget blueprint. So I'm going to call the content drawer by pressing Ctrl and space. I'm going to go to the folder content, then funky shooter, and here I'm going to create a folder. Right click, new folder, and I'm going to call this folder UI. Then I'll go in this new folder. I'm going to right click, select user interface, and select widget blueprint. Here I'm going to select user widget, and then I'm going to rename it to WBP for widget blueprint underscore and game screen. Now I'm going to open this new blueprint, and when we want to create user interfaces, we use what we call UMG, which stands for Unreal Motion Graphics. The interface is quite simple to understand. At the top right corner, you can switch between the two available modes of the UMG. The workflow when using UMG is quite simple. First, you use the designer, we are in the designer mode right now, to draw your user interface by placing buttons, text, and everything that is related to the visual aspect of the menu. Then you go in the graph mode here, to implement the logic you need to make your menu react to the player's input. For example, it's in this graph that will implement the ability to restart the game when the player clicks on the restart button. So now we are going to design our menu in the designer. First, we are going to take a canvas panel. So here there is the look of the menu once we add it to the screen. So first we need a canvas. We're going to take here canvas panel and drag it in the viewport. So now we have the screen that is displayed right here, and I'm going to add a text which says that the game is over. So I'm going to take here in the palette, we have a lot of things such as buttons, checkboxes, images, progress bar, and a lot of things. Then I'm going to take here the text. I'm going to place it in the canvas here. And then, as you can see here, we have the anchor point. This means that when the screen is resized, this text respects the distance from the anchor point. What we want to do is to anchor the text at the center of the screen. So I'm going to take the text block here, and I'm going to go to anchors here and select this one. Now you can see that the flower, the anchor, is anchored in the center of the screen. Then I'm going to change the size of the text by going here, the size option here, this one. I'm going to put it at 100. Then I can go here and select size to content because you can see that the box, the slot in which the text is placed is too small for the text. So I'm going to take size to content and check it here. Then the alignment, I'm going to put 0.5 and 0.5 so that the pivot point of the text is at its center. And then I'm going to place the text just above the center of the screen. You can center it exactly at the middle on the horizontal axis. By going here in position X, you can put the value of 0. Now I'm going to change this text to game over. Here you have the text option right here. You can write game over, and you will see that the text will be updated. Here we have game over on the screen. Now I would like to add a button that can restart the game as soon as we click on it. So here in the palette, we have a button. We're going to take it and drag it in the canvas. We're going to change its alignment. We're going to put here 0.5 and 0.5. Okay. Then we are going to check size to content, which will shrink the button right here. And we're going to put inside this button a text. So widgets in Unreal Engine, in UMG, can be placed inside another. So I'm going to take the text here. I'm going to put inside the button right here. And the text will be inside the button. So the text, I'm going to change it to write, let's say, restart. I'm going to change its size right here to 50. And then I'm going to take the button and put it in the middle here. The anchors I'm going to put in the middle and change the position X to 0. Then I'm going to rename this button by going here, this place. You can select it and rename it to restart button btn because we are going to use it later. Okay, so now that it's done, we are going to use to find a way to display the current score. So I'm going to take a horizontal box, which represents like a panel that can organize widgets horizontally. Okay, so I'm going to take a horizontal box, put it right here, change the alignment to 0.5, 0.5, then anchor, we're going to make it to the center, and change the position in X to 0, and position in Y to minus 100 maybe? No? 0? Okay, 0. 0 seems cool. So I'm going to check size to content. And then in this horizontal box, I'm going to drag a text here. This one I'm going to drag in horizontal box. This will add a text block. I'm going to take the horizontal box and put it slightly up, minus 50. So we can see what's displayed in the box. And then this text, I'm going to change the text to your score equals space. Let's change its size to 40 here. Okay, and now we want to display the score. So we take another text and put it in the horizontal box. And you can see that this doesn't have the same size. So we can either change the size of this text or simply select the score, right-click, and duplicate. Now we have the same parameters, the size, and everything else. So here the text, we're just going to make to put a placeholder, like 5,000, for example. It's over 5,000. Okay, I'm going to compile and save, and we are going to change the value, the name of this widget here. We are going to change to my score, and we are going to check is variable. It's important. You need to check if restart button is variable is checked too, because we are going to use both of them later in this tutorial. This one will be changed dynamically based on the score of the player, and this one will trigger the restart of the game when we click on it. Now that the visual aspect of the menu is done, we can start wiring everything in the graph of the widget. First, we'll start by adding the possibility to restart the game when the player clicks on the restart button right here. So if we select the restart button and we go down the details panel, we can see down in the right corner that there is a lot of event that can be triggered based on what happens to the button. The one that we are interested in is the unclicked button, which is called, you guessed it, when the button is clicked. So I'm going to click on this plus sign next to unclicked, and you will see that this will add an event in the graph. As I said earlier, this event will be called when the restart button will be pressed. And what do we want to do when the restart button is pressed? We want to restart the game. And there's a blueprint node which does exactly that. So unclicked restart button, I'm going to draw a wire and call open level. Open level by object reference. Then I'm going to select the input level and select the main map. The main map is this one. You can see its name right here, main map. So I'm going to compile and save, and that's it. An important thing to know is that even though we just open a level, the main map, what will happen is that the game will be completely restarted and the game will restart itself from the beginning. So now that we've done the restart button part of our user interface, we are going to show the score of the player to the screen. The score of the player will be represented by the amount of time elapsed since the game started. We are going to update this placeholder value with the real score, and to fetch this amount of time elapsed since the game started, Unreal Engine 5 has a blueprint node that does just that. So I'm going to go in the graph, and here I'm going to right click, type get player pawn, and select game get player pawn. So this node gets a reference to the player pawn, this one, the pawn that is controlled by the player. Then from this get player pawn, we are going to draw a get game time since creation. This function, which is stored in the pawn class, returns the time elapsed since this pawn was created and spawned into the game. So now the question is, where do we need to plug this return value so that the text on the screen is updated correctly? To find an answer to this, we are going to go to the designer and select this widget. This widget if you remember well, we renamed it to MyScore and checked the is variable checkbox. What this does is that when you go to the graph, you can see that we have MyScore that is accessible right here. So I'm going to take this and get my score. And then I'm going to draw a set text node from my score. And what this does is that it's going to change the text here by the one we input here. And how do we change this to this? You can see that these are not the same color, so they are not compatible. So I'm going to draw a wire that I'm going to connect right here. And you will see that this will create a node that can convert this value, this number, to a printable text. So now that I have this code works as follows. First, we take the time elapsed since the player character was created. Then we convert it to a displayable text. And finally, we replace the text that is displayed on the MyScore text of the designer, this one. So now where do we need to call this logic? It's easy, since we will be displaying this menu as soon as the player is dead. We can use the event construct. So this one, the event construct here, which is the equivalent of the begin play event for user widgets. So I'm connecting this one to set text. And this means that when the player's health points reach 0, we display this widget and fetch the time elapsed since creation to the player to show it on the screen. Okay, so now that the menu is finished, we just need to show it on the screen at the right time. But before going further, I hope you have enjoyed this tutorial so far. If so, it would help me a lot if you could hit the like button for the YouTube algorithm to show my channel to more people. I'm so sorry for my English. I promise I will get better. This is not my native language. I'm French actually. Thank you for liking the video, and let's get back to the tutorial. So now, how do we show the widget we created on the screen? To do so, we are going to go in the blueprint of the player. Here we have the actor begin overlap. We check if it's an enemy. We remove some health points from the current health points of the player. We check if he doesn't have health points anymore. If so, we print the string on the top left corner of the screen. So here, instead of printing this message on the screen when the player is dead, we are going to show our menu. I'm going to code something and explain to you after that. Here I'm going to delete this print string. I'm going to right click, create widget, select this node, connect this to the true execution wire, and here to the class we're going to select our WBP underscore endgame screen. Then once the widget is created, we are going to add it to the screen, in other words, to the viewport, by drawing a wire from here and calling add to viewport. This one, add to viewport. The way this code works is simple. First, we need to construct the widget, and then we add it to the viewport. Now I can launch the game, and as soon as I'm dead, the menu should be shown on screen here. So now, as you can see, there's two problems. First, the game keeps running even after the player is dead. And second, we don't see the mouse cursor. Therefore, we cannot click on the button to restart the game. First, we are going to pause the game so that the player can no longer move. And as usual, in Unreal Engine 5, there's a blueprint node that does just that. I'm going to go here, select these nodes, put them over there. And here, I'm going to draw a cable from the branch through execution pin and type set game paused. Here I'm going to check, and what this does is that as soon as we go through here, we are going to pause the game just as the name suggests. So don't forget to check this checkbox. And here, if I launch the game, you can see that when I die, there's the game over screen that appears. The game is paused. You have your score, but you cannot click the restart button because you don't have your mouse is not showing. So now we want to show the mouse cursor as soon as the menu is displayed on the screen. And you guessed it, there's a blueprint node doing just that. To do so, we need to set the value of a variable that is stored in the player controller, which is the interface between the player and the playable character. So I'm going to select those nodes, put them over here, and here I'm going to right click, get player controller, And from the get player controller, I'm going to draw show mouse cursor. You see, show mouse cursor is a variable that is stored in the player controller, and you can either get or set this variable. So us, we are going to take the set show mouse cursor because we want to change its value. And here you can connect it to the set game posed and to the create widget. And here you just need to check this checkbox. So when the player dies, we pause the game, we show the mouse cursor, don't forget to check this part, and then we add the widget to the screen. So let's launch the game to see if it works. So here, now I'm dead. I have the mouse cursor right here, I can click anywhere, and if I click on restart, I can restart the game. Okay, so now the game is slowly taking shape, and now we are going to add a health bar in the game. We are going to create a second user widget that will show a health bar at the top left corner of the screen instead of printing a string. So let's call the content drawer by pressing Ctrl and spacebar on the keyboard. I'm going to go in the UI folder, so content, funky shooter, UI, and here I'm going to create a new user widget. Right click, user interface, widget blueprint. So select user widget and call this one WBP for widget blueprint main HUD, the main heads up display. So what we want to do with this widget is show it on the screen as soon as the game starts. To do so, we are going to add it to the screen from the player. So here, that's great because I'm already in the blueprint of the player, and I'm going to add a begin play. Here, right click, begin play. And as I said earlier, the begin play is the event that is called as soon as the player enters the game, as soon as the actor enters the game. So here I'm going to create my widget, create widget. I'm going to select my WBP main HUD, and then I'm going to add it to the viewport. Add to viewport. I'm going to select this one. And here, if I launch the game, I won't see anything because I still haven't designed my widget blueprint. So I'm going to open my WBP main HUD, Control Spacebar, UI, WBP main HUD. I'm going to double click on it. And here I'm going to design my health bar. So first, as usual, we're going to add a canvas panel here. Okay, so now that we have a canvas panel, we are going to use what we call a progress bar. The progress bar is here. Progress bar. I'm going to select it and drag in the canvas panel. And the anchor point is at the top left corner of the screen, so it's okay. I'm going to resize it by clicking right here. Yes, place it where I want. Resize it a bit. And I'm going to rename it to life gauge. Now, I'm going to go to the details, and here you have the percent parameters, which controls the filling of the gauge. So 0 means it's empty, 1 means it's full, and 0.5, for example, means it's half full. Now we can choose if the progress bar fills from the left or from the right by selecting here, bar fill type. I'm going to put myself in the middle of the screen. No, the left small. Okay, the bar fill type here, we can choose, for example, for right to left. The health bar will fill from right to left, but we are going to keep it classic and put it from left to right. Okay, so we can also change its color. I'm going to go here in fill, color, and opacity. I'm going to click on this and select a new color. Let's say pink, for example. Seems to be a good orange. Let's go for orange. I'm going to click on OK. And now, if I launch the game, I can see that the health bar appears on screen. So, since we want to update the gauge fill level based on the player's health points, we need to find a way to get this info in the player. There are multiple options to do so, but I'm going to show you the simplest but not optimal one, which is the binding of a new function. So I'm going to select the progress bar, and here in the details, I'm going to go to %, and here you have an option which is called bind. I'm going to click on this and create binding. This will create a function that I will rename by going here. I'm going to click or press F2 and select and rename it to update life bar. Okay, so what we've just done is bind the percentage of the life bar. So here, the percent, we made a bind to a function. Okay, so a function is like an event, but with some notable differences, such as having the ability to return a value once the function finishes executing. Here we can see that the function returns a value of type real, which represents the percentage that will be applied to the progress bar. So here, for example, we have the value 0 that is returned, and if we launch the game, we can see that the health gauge is empty. If we put, let's say, 0.3 and launch the game, we can see that it's filled by a value of 30%. So now that we made the binding, we just need to get the player's health points. To do so, we just need to access the player, which is possible anywhere in the code, thanks to the blueprint node that we used earlier, which is called, right-click here, get player pawn. Remember that this node can get a reference to the player pawn in the world from anywhere in the code. Here, we know that it's a pawn, but we would like to tell Unreal Engine that it's, in fact, a BP underscore player. So from the get player pawn, I'm going to draw a cast to BP underscore player, and I'm going to connect this to the entry of the function. We used the cast earlier, and just as a refresher, if the player pawn that is fetched by the get player pawn is a BP player, we go through this execution pin. If it's not, we go through this one. Okay, so of course we know that it's forcibly a BP player, so we know that it will forcibly go through this execution pin. So now that Unreal knows that this pawn is in fact a BP player, we can get this actor through here and access its value current health points. In fact, a player pawn, if you draw a cable from here and try to get current health points, you can see that it doesn't have any variable that's called the current health points. Why? Because for Unreal, a pawn doesn't have a variable that's called current health points. But by saying to Unreal that this is in fact a BP player, Unreal now knows that this is a BP player and that a BP player has a variable get current health points here, as you can see here. Now, if we try to plug the value of the current health points inside the return value, this won't work. Why? Because if you remember well, in the designer, when I choose the life gauge, you can see that the percent goes from 0 to 1. However, when you take the current health points that we coded earlier, the current health points goes from 0 to 100. So we need to format this value so that it goes from 0 to 1. And to do so, we just need to convert the current health points to a value of 0 of 1 by dividing it by 100. So I'm going to draw a cable from current health points here, and I'm going to type divide and get the operators divide, this one. Just like the subtract operation that we used earlier, it takes the top value, current health points, that is connected to the top pin, and then it divides it by the bottom value, which is 0. We're going to put it to 100. So by dividing the current health points by 100, we are going to have a value that is between 0 and 1, and that can be plugged in the return value. So now I can connect the two, the cast node and the return value node. And before going any further, I would like to tell you something about optimization. As I said earlier, since this code is called every frame, it's not optimized because we don't lose health every time the frame is refreshed. We could just update the life gauge appearance every time the health points decrease. But since we are just beginning with Unreal Engine 5, we just want the code to work and don't need to optimize a lot. So now I'm going to go to the BP player. Then I'm going to search for the event tick, this one, and I'm going to delete it since we don't need to print the current health point on the string on the screen anymore. So I'm going to delete this one. I'm going to launch the game, and here you can see that we have a functioning life gauge. The life gauge is slowly depleting, and as soon as it reaches 0, it's a game over, and you can restart the game from start. Now the game is fully playable, we can dodge the enemies, survive as long as possible, and it's great, but we are going to give the player the ability to attack the enemies by throwing deadly projectiles at them. First, we need to create an actor that represents a projectile. I'm going to go to the content by pressing Ctrl and space on my keyboard. Then I'm going to go to the folder blueprints. So content, funky shooter, blueprints. And then here I'm going to right click, create a basic asset, blueprint class. And I'm going to select actor. Why actor? Because since it's a projectile, it doesn't need to be controlled by a player or an AI. It will just go towards the top of the screen. So I'm going to select actor. I'm going to rename it to BP underscore projectile for blueprint projectile. And then I'm going to open it. So here I will be adding first a visual representation of the projectile. I will add a static mesh here. I'm going to click on add to add a new component. I will select static mesh. And over here, I'm going to set the static mesh to SM projectile. So the projectile is too big, so we are going to rescale it. I'm going to put it back, the scale to 0.7. And just like the skeletal mesh of the player, the static mesh is just a visual representation of the projectile, and we need to add collision so that it can overlap enemies and deal damage to them. So here I'm going to add a sphere collision component. I'm going to click on add again. I'm going to type collision, and I'm going to select the sphere collision component. I'm going to put it as a root, as I did with the player. And then for the sphere radius here, I'm going to scale it, make it a bit bigger because it's too small based on the static mesh. So here I'm going to put a value of 38. And now you can see that the sphere collision is bigger than the projectile static mesh. So I'm going to save. I'm going back to the viewport. And here I'm going to place the projectile in the world. I'm going to put it down so that it can be close to the player. I can put a value of 0 in Z, in the Z axis. And if I launch the game, you can see that just like the player at the beginning of this tutorial, the projectile is not moving because we didn't set it up so that it can move like a projectile. Now, I think that you are used to it, but Unreal Engine 5 has a component that does just that. We are going to go to the BP projectile again, and we are going to add a new component called projectile movement. As I said earlier, once this component is added to the actor, it can simulate the behavior of the projectile. But before trying it out, we need to set up some parameters. So let's select the projectile movement. And in the details panel right here, I'm going to set initial speed to 1000, max speed to 1000, so that the speed is constant. And then we are going to set initial velocity in local space. Right here, we're going to put it to false, so that the velocity that we are going to assign to the projectile will be in world space. We would like to make the projectile go along the x-axis of the world and not of the projectile. And then what we are going to do, the projectile gravity scale, we don't want any gravity applied to the projectile right here. So we are going to put this value to 0. And finally, the velocity that you see right here in the details panel, you need to check if it equals to 1, 0, 0, so that it's along the x-axis of the world. So now I can go to the viewport, compile, save, go in the viewport, and here I will make a simulate. Simulate, just as a refresher, it's like launching the game, but without taking possession of the player and seeing the action apart from the main camera. So here I can click on the 3 dots and select simulate, and you can see that the projectile goes far, far, far away. As you can see, there's a problem with our projectile. When it spawns in the world, it lives indefinitely even when it leaves the screen. To fix that, we can define a lifespan for the projectile so that it auto-destroys itself after a set amount of time. To do so, we are going to go to the projectile and select class defaults. And here you have a parameter called initial lifespan. Here, actor can be damaged, initial lifespan, this one. Initial lifespan, we're going to go put a value of 5. And now I can compile, go back to the viewport, and launch the simulation. And you can count with me. 1, 2, 3, 4, 5. And now the projectile will be destroyed 5 seconds after it spawned in the world. So now that we have a working projectile, we would like to be able to fire them with the press of a button. To do so, we are first going to add an input to our project so that we can use the spacebar, for example, to fire a projectile. So I'm going to go to Edit, Project Settings, here, and then in the Input Engine, Input right here, I'm going to add this time an action mapping. I'm going to click here on the plus sign. I'm going to rename this action Fire Projectile. And then I'm going to assign first to the gamepad face button bottom, which correspond to the A button, this one on an Xbox controller. And then I'm going to add another binding here and click on the keyboard, the small keyboard, and press the spacebar. So as you can see here, we defined an action and not an axis. And what's the difference? Contrary to an axis action that is fired every time at every frame, this action is not fired at every frame. Instead, it's fired when you press the button that is bound to the action and when you release this button. Now I'm going to go to the BP player. I'm going to go in the event graph here. I'm going to right click and call Fire Projectile. So Fire Projectile will be called every time we press one of these two buttons. When we press the button, so the spacebar, we go through the pressed execution pin. And when we release the spacebar, we go through the released execution pin. Of course, what we are interested in is the pressed execution pin. So when we press the spacebar, we go through here and we would like to spawn an actor of type BP_projectile so that it can go towards the top of the screen. So in order to spawn an actor, you guessed it again, Unreal Engine 5 has a blueprint node that can do it and which is called spawn actor. So I draw a wire from the pressed execution pin and called spawn actor from class, this one. Here I have to define what type of actor I want to spawn, and I'm going to select the BP_projectile. This one, BP_projectile. Here, if we try to compile the code, we will get an error here because this node needs a spawn transform to work correctly. So what is a transform? It's a type of variable that combines a translation, a rotation, and a scale. You can see it by right-clicking on the spawn transform here and select Split Struct Pin. This will break this spawn transform into all of its components, which are the location, the rotation, and the scale. So now if I compile, it works because it knows now that it should be spawned at the origin of the world with a rotation of 0, 0, 0 and with the scale of 1, 1, 1. So if I want to recombine everything, I click on one of the components and select Recombine Struct Pin. So what transform do we need to plug in? We could take the transform of the player, so we will get the position of the player, but that would make the projectile spawn directly on the player. Instead, we are going to add a component in front of the player so that we can spawn projectiles at its transform instead of at the transform of the player. So I'm going to go to the viewport here, and I'm going to add a new type of component called arrow, this one. I'm going to click it. This will add an arrow, which is just like a visual cue. And I'm going to place it, select the X, and place the arrow far enough from the player so that when the projectile spawns, it doesn't collide with the player. So I'm going to put at, let's say, 220. And now that our component is placed correctly, we can compile and we go to the event graph. Oh, I have a small problem because of the spawn actor or problem that we saw earlier. So I'm going to split struct pin, compile so that there's no more error. And then we can assign the transform here, right click, recombine struct pin. We can assign the transform of the arrow. So I'm going to get the arrow here, put it right here. That makes a get operation for the arrow. And then from the output of the arrow, I'm going to draw a get world transform, which gives me the transform of the arrow in the world at the moment that we call this node. So here, now that we have the world transform of the arrow component, we can plug it in the spawn actor BP projectile spawn transform. So now, if I compile, there's no more error. And if I launch the game, select selected viewport, you can see that I can fire projectiles when I push the spacebar. So now I'm going out of the game, I'm going to the viewport and delete the projectile that we placed earlier because we don't need it anymore. So now that we can spawn projectile with the press of a button, we would like to deal damage to the enemies when a projectile overlaps with them. To do so, it's going to be quite simple since we have already done something similar when we were working on dealing damage to the player. So I'm going to exit the execution of the game. I'm going to go to the BP_projectile, the event graph. And what we are trying to do is when a projectile overlaps an enemy, the enemy is destroyed. To be able to detect the moment an enemy overlaps the projectile, we are going to use the event actor begin overlap that we used earlier. So here, I'm going to take the event actor begin overlap. I can delete the begin play and the event tick. And here, when an actor overlaps with the projectile, we need to check if the actor is of type BP_enemy thanks to a cast to BP_enemy node. So I'm going to draw a wire from the other actor parameter and call cast to BP_enemy. So now you know the drill. When we go through the event actor begin overlap, we take the actor and we tell Unreal that if it's a BP_enemy, we want to go through here. And in our case, if the actor is of type BP_enemy, we want to destroy it. And you know the drill too. With Unreal Engine 5, there's a blueprint node that can do just that. So I'm going to draw a cable from the as BP_enemy, which represents the other actor as a BP_enemy. And then I'm going to type destroy and select destroy actor. That's it. If you launch the game, you can see that the projectile kills the enemy. But there's another problem is that if I throw a projectile at one enemy, it still continues to live. The projectile doesn't destroy itself, and it can potentially destroy many enemies. So we don't want that. We would like to be able to destroy the projectile as well as the enemy when the projectile overlaps with an enemy. I'm going to draw here another destroy actor. I'm going to draw a line here, a wire, destroy actor. I'm going to select the destroy actor. And here, I don't need to connect anything because, as you can see in the input, it's written self. Self means that this actor, the actor in which this node is called, will destroy itself. So if I launch the game, you can see that the projectile kills the enemies and destroys itself as well. Let me tell you something. At this point, you can be proud of yourself because you did it. You created your very first game with the Unreal Engine 5. It's great, of course, but did you know that there's a lot of awesome things that you can do with Unreal Engine 5 that you might not know of? If not, and if you want to know more about this wonderful engine, click on this video and I'll see you over there. Project that I made, oh, right here, yes. Cube shrinked, or just like you saw right here, right now, right here.